Hey everyone, and welcome to This Explainer. Okay, today we're jumping right into a super important pre-flight briefing for all you student pilots out there. We're going to take the aerodynamic theory of flaps and translate it into actionable, safe procedures for your descents. We'll break down exactly what happens to your aircraft the moment you reach for that flap lever. Let's start by looking at a classic problem you're definitely going to face when approaching a landing. Picture this. You're a bit high on the approach, right? You need to lose altitude quickly to hit your touchdown zone. But if you just shove the nose down, gravity takes over and your airspeed absolutely shoots up. And honestly, that's a really dangerous situation. So the big question is, how on earth do you steepen a descent without gaining all that dangerous airspeed? Well, here's our flight plan to figure that out today. 1. Why we use flaps. 2. The aerodynamics of lift and drag. 3. How to actually extend flaps. 4. The critical importance of trim. And 5. Retracting flaps safely. All right, let's kick things off with section 1, why we use flaps to solve this whole descent problem. Think about what's actually happening mechanically. When you extend the flaps, you are physically altering the shape of the airplane's wing. Doing this gives you a small bump in lift, but more importantly, it creates a massive proportional increase in drag. It's kind of like throwing out an aerodynamic anchor. Plus, and this is key, it lowers your stalling speed. That lowered stalling speed is really the magic ingredient here because it allows you to fly safely at a much slower pace while still keeping a comfortable safety margin above the stall. Moving right along to section 2, aerodynamics, specifically lift and drag. Let's dig into how these physical changes actually alter the view out your windshield. Just look at the visual perspective here. On the left, we've got a clean aircraft. On the right, the flaps are fully extended. Now, because of that huge increase in drag we just talked about, maintaining your airspeed actually requires you to lower the aircraft's pitch attitude. And notice what happens when you do that. That lower nose brilliantly brings your ground aim point much closer into view. When you're on approach to land, being able to clearly see the runway right over the cowling is just a massive advantage. Now, this shifted perspective doesn't happen by magic. It's caused by the invisible aerodynamic forces at play. When you deploy those flaps, that giant drag penalty basically pulls the aircraft into a progressively steeper flight path. So you get a higher rate of descent without accelerating. You're effectively riding all that extra drag safely and completely under control right down to the runway. Okay, section 3, how to extend flaps. The theory makes total sense, but let's get practical and walk through the exact physical process of lowering the flaps in the cockpit. Before your hand even goes near the flap lever, you have to look at your airspeed indicator. See that white band? That right there is your flap operating speed range. The very top end of that white arc is your VFE, the maximum flap extension speed. Remember, extending flaps changes the wing shape and creates a ton of extra stress on the airframe. So absolutely crucial point here. You literally must verify that your airspeed is below VFE before extending the flaps. No exceptions. Okay, so once you've verified your speed, here are your 4 deliberate steps. 1. Check airspeed is below VFE. 2. Lower the flaps in stages. Don't just dump them all at once. 3. Set that lower nose attitude we talked about earlier to maintain your desired airspeed, controlling it with the elevator. And 4. Trim. This whole process needs calm, really methodical execution. Which leads us perfectly into section 4, the importance of trim. Honestly, this step is so critical to smooth flying that we're giving it its own spotlight. Here is your golden rule. You must retrim after every single stage of flap extension. Why? Well, because lowering the flaps moves the wing's center of pressure, which is the point where lift acts either forward or backward. It also totally changes the airflow hitting your horizontal stabilizer. All of this creates a really strong pitching tendency. Sure, you can find it with the control column, but you have to trim off that steady pressure. If you don't, you'll literally be arm wrestling the airplane, like you're holding a heavy dumbbell the entire way down to the runway. Finally, we've made it to section 5, retracting flaps safely. We got them down, but what goes down must come back up, right? And retracting them introduces a totally different set of aerodynamic challenges. Listen up, because this is a really critical safety warning. When you raise the flaps, you are instantly stripping away that extra lift you created. If you don't proactively adjust your nose attitude, the airplane is literally just going to sink. On the flip side, lowering the flaps causes a ballooning effect. You really have to anticipate these reactions. And hey, Never ever raise the flaps at speeds below the green band on your airspeed indicator. Why? Because the bottom of that green arc is your clean stalling speed. Let's put this side by side to make it crystal clear. Extending flaps lowers your stall speed and requires a lower nose attitude. Retracting them increases your stall speed and requires a higher nose attitude to keep you from sinking. This is wildly important during a go-around from a discontinued approach. If you apply maximum power while retracting those high-drive landing flaps, it causes a massive pitch-up tendency that you have to actively fight with forward control pressure. So again, retract in stages at a safe speed. So consider this your final pre-flight checklist, the golden rules of airmanship for flap operation. Never exceed VFE. Never retract below the clean stalling speed in the green arc. Always operate the flaps in stages. Hold your desired pitch smoothly. Anticipate the ballooning or sinking. And always, always retrim to relieve that control pressure. Which leaves us with this final thought for today. You now know exactly what's happening to the wing, the lift, the drag, and the airframe when you operate the flaps. You've got the theory down cold. So, on your very next approach, are you going to let the airplane fly you, or are you going to use the physics of drag to actively command that descent? Really think about that the next time you take the yoke. Thanks so much for joining me on this explainer, and safe flying out there.